So I am going to replace the values of theta, the theta and cos theta. So from whatever we already wrote, we know that d theta is equal to, d theta is 2 dt, 2 dt, all this divided by 1 plus t squared. And this is divided by 5 plus 4 cos theta. And cos theta in terms of t is the same as 1 minus t squared. All this divided by 1 plus t squared. Okay, fine. So I would like us to simplify that. So we have 2 dt, all this divided by 1 plus t squared, and then divided by, so let's put this other side, everything on the, like in the same LCM. So let's have this over 1. So what will our LCM be? Our LCM will be 1 plus t squared. 1 goes here, 1 plus t squared. So I'll have 5, 1 plus t squared plus 4, 1 minus t squared. 1 plus t squared goes here 1 time. So that basically simplifies to that. So I can choose to simplify what's on the numerator over here. So this will basically be 5 plus 5t squared plus 4 minus 4t squared, which basically gives the constants 5 and this 9, 5t minus t squared. So we have integral of 2 dt over 1 plus t squared. Divide by is the same as multiply by the reciprocal, which is 1 plus t squared. All this divided by what's on the numerator, which is now 9 minus t squared. This and this will cancel out so that I have integral of 2 over 9 minus t squared dt. And clearly we can see whatever we have down here on the numerator is clearly, we can be able to write this. We can be able to write this so that, let's see, so that we have, Okay, fine, guys. So this is plus t squared. 5t squared minus 4t squared gives us plus t squared. So this is plus. So if I write this way, 2 over t squared plus 3 squared dt, then clearly it resembles this particular integral. From the tables, we all know that if you have the integral of this form, 1 over x squared plus a squared dx, then the integral of this is tan inverse of x over a. So integrating this, we are going to have, so the integral of this is going to give us the integral of this is going to give us, so in a similar manner, this is going to be 2 into 1 over 3 tan inverse of t over 3 plus c. Now you should check on this integral, this one here. It can also, this is 1 over a, sorry. So it's supposed to be 1 over a tan inverse. It's a standard integral in the SMP. So what I've done is I've just taken out the 2 outside. So taking the 2 outside here, then 1 over a is 1 over 3. Tan inverse of x over a is 2 over 3. And that's basically what that gives. Okay, fine. So that's how we go about those questions, guys. I would like for me to do one last example, and then you guys can be able to do exercise 167 in a similar manner. Hello? I hope that's clear. Okay, example, let's have it as example 5. So we have integral of d theta over 4 cos theta plus 3 sine theta. So let's go on with the substitution. So substituting the value of d theta, cos theta, and that. So this will be the integral of the substitution for d theta. D theta is the same as 2 dt, all this divided by 1 plus t squared, divide by 4 cos theta. The substitution for cos theta is 1 minus t squared, all this over 1 plus t squared, plus 3 into sine theta. The substitution for sine theta is 2t over 1 plus t squared. Okay, fine, let's simplify. So I have 2 dt over 1 plus t squared divided by, so on this side, I will have, if, let's put this under the same LCM. So I have 1 plus t squared being common on this side. So I will just have this as 4 minus 4t squared plus 6t. Okay. Simplifying that, so I have integral of 2 dt, all this divided by 1 plus t squared. Divide by is the same as multiply by the reciprocal, 1 plus t squared over, so 4 minus 4t squared plus 6. So I have 4 minus 4t squared plus 60. Okay, so this and this cancel out, so that I remain with integral of 2 dt, all this divided by 4 minus 4t squared, 4 minus 4t squared plus 6t. Okay, fine. So as we can see, 2 is common both up and down. So I can factor out 2. I remain with dt here, and factor out 2 on the numerator as well. I will remain with 2 minus 2t squared plus 3. So then now we integrate whatever we have there. So we are evaluating the integral of, dt over dt over 2 minus 2t squared plus 3. I want to write it this way. This is the integral of 1 over, so I can have this as, let's say I take out minus outside. So I can have, let's say, minus 1 over here, so that I have this as t squared. There's some t that's missing. There was t here. So t squared minus 3t minus 3t minus 2. And there's 2 here. So what if I get rid of this 2? If I factor out the 2, then this will be 3 over 2. Then this will be 1. Just trying to simplify dt. So I have minus a half into 1 over t squared minus, this is 3 over 2, 3 over 2 t minus 1 dt. Okay, fine. So I can be able to complete the square for whatever we have down there. So I will have minus a half into 1 over, completing the square in the denominator, we will have t minus 3 over 4 squared minus 25 over 16. Okay, so this is basically the same as us writing minus a half integral of 1 over 25 over 16 is basically 5 over 4 squared minus t minus 3 over 4 squared dt. Okay, and evaluating the integral of this. This is also a direct integral in the SMP. So you check on page 11, the integral will be minus a half into 1 over 2 5/4 ln 5/4 plus t minus 3/4. All this divided by 5/4 minus t minus 3/4. Plus c. Okay, so that's it. But remember that our final answer is supposed to be in terms of theta. So where there's t, we replace with tan theta over 2. Where there's t, we'll replace with tan theta over 2 and basically simplify. So if we replace where there's t with tan theta over 2, our answer will be much simpler. If we replace and evaluate, we should be able to get this a half plus tan theta over 2 minus tan theta over 2 plus c. Okay, someone has raised up their hand. I want to take up the question before time is up. What's the question? Joseph Washira, your hand is up. Kindly ask. What's the question?
Kindly, madam, repeat from hapo kwa 20.